Hello, fellow components. I'm the Teenage Astronaut. This is Rapid Space History. In today's episode, we're talking about the Sea Dragon. Sea Dragon was a conceptualist American rocket that started its construction in the early 1960s. Let's get straight to the basics. Sea Dragon would have been a super heavy lift vehicle, meaning it could take at least 50 tons to a low Earth orbit. Some other vehicles of the same class that are simply recognizable is Starship, SLS, and Falcon Heavy. Sea Dragon, though, would have been the king of the hill, being able to lift a giant 550 tons to low Earth orbit. Fun fact, Sea Dragon could actually lift the entire International Space Station to orbit in one launch. That's giant. Sea Dragon was designed by Aerojet before most Aerojet Rocketdyne in the early 1960s. It would have launched from the middle of the ocean. Not joking. This is due to multiple reasons, but one of the big ones being it wouldn't need giant launch infrastructure. Like, think about how big the pad, the launch complex, all that stuff, and like the assembly building would have had to be for a rocket that is hundreds of meters tall. And it was all built at once in the 1960s. The man behind, though, this crazy idea was as far as some people are concerned, absolute lunatic, but just a guy named Robert Truex. Sea Dragon had three parts to it: the ballast tank, the rocket, and, of course, the payload. Of course, that a payload. The first stage would have been powered by an absolutely gargantuan, massive engine that would have measured around 24 meters in diameter. And at the bottom of the nozzle, and produced 350 meganewtons of thrust. Meanwhile, the second stage would have been powered by another giant engine measuring around 23 meters at the base, and would have produced 59 meganewtons of thrust, nothing compared to the other one. The first stage burned a Kerolox fuel, which, if you don't know, is the same fuel done on Falcon 9. This means it has, for fuel, kerosene, oxidizer, liquid oxygen. The second stage burned a much more conventional for NASA fuel, and that is a Hydrolox fuel, meaning that the fuel in it is liquid hydrogen, and the oxidizer is like Kerolox, liquid oxygen. The first stage would have burned for roughly 81 seconds, which, if you don't know the math on that, translates to around a minute and 11 seconds. And the second stage would burn for 260 seconds, which translates to roughly, let's think about that, 2 minutes and 20 seconds, so 180 for 3 minutes, 280 plus 30, 10, so 240, so just under 4 to 5 minutes of burn time on that one. The ballast tank, it had two main functions. The big one, though, was keeping it straight up and down pre-launch, before the engines would ignite, which is a big thing, because you don't want your giant-ass rocket tipping over in the water uncontrollably. And also, so that they could actually sink the rocket down, so the payload was, could be, messed around with and whatnot by the crew. Now, let's talk about the launch sequence of this thing. This is where it gets borderline insanity. A typical launch sequence would start with at least part of Sea Dragon being refurbished and mated to the rest of the vehicle, whatever that was, while on shore. It was also during this time that the kerosene, or the RP-1 as it's officially called, would be loaded onto the first stage. Once this was done, it would be towed out to the launch site, very likely by a tug, because what else would it be like on the barge, maybe. Once at the launch site, though, the liquid oxygen and liquid hydrogen would both be produced on site via electrolysis, which is the process of using an electrical current, a direct electrical current, to basically split molecules apart. So, split the H2O molecules into hydrogen and oxygen. Yeah. That's an actual thing, and in the movies, still. Not just in the movies. Truex, the designer, suggested during this phase, due to the immense amount of electricity necessary for this, that the rocket and some of its supporting systems should be powered by a nuclear aircraft carrier. I'm not joking. That's where it gets borderline insanity. The ballast tanks would then be filled with water, sinking the rocket down to around the second stage. Last minute checks would be done, then Sea Dragon would whisk off into the sky to launch something somewhere. This is all planned out. All this would have happened. What happened that caused this to not happen? Sea Dragon was given the go for construction. Designs began to be done. All this stuff happened. But in the end, it got cancelled due to budgetary pressures. And sadly, for a lot of vehicles like it, the main launch vehicles that are commonly referred to as big and dumb boosters, due to their simple way they are designed to be, also got cancelled, as the American space programs, at the very beginning you could say, kind of started to focus on other things, mainly like chucking people into space, not giant rockets. In the end, the closest we got to seeing a Sea Dragon launch was in, by the spoiler alert, beep beep beep, was in For All Mankind, as that is a rocket that is launched in that series. Multiple times, in fact, at least twice, because you see it twice, but very likely more than that, is it actually mentioned to be launched at least 3 times, but still, likely more than that. And I personally, actually, this is the first time I have a personal opinion that's maybe not what you would expect. I am extremely Team Space. So, I literally have a shirt somewhere that says Team Space on it. I think this was a good thing. Because if Sea Dragon had launched and had happened, it's very likely that other ones would have hit well. And some stuff that happened in space flight history that I will very like to talk about later on in the series probably wouldn't have happened. And stuff like the Apollo program probably would have been pushed back. And we probably wouldn't. It's possible that America wouldn't have landed on the moon in 1969. It's possible to have done it earlier. Could in 1966, for all we know. Because it was just a giant-ass rocket. But also, I know there was evidence to show that Sea Dragon probably would have failed. Because, simply, they were trying to make a giant Earth rocket in the 1960s that would have been nearly fully reusable. Keep in mind, NASA wasn't able to really make a partially reusable, affordable space plane in the 1980s and 70s. So, no way Aerojet would have done it in the 1960s. Basically. Which is why it's kind of a good thing it didn't happen. But, that is it for this episode of Rapid Space History. I will see you all next week on the next episode, which we'll be talking about something quite interesting, I think. And I'm not going to say anything about it. If you want to see that, well, check back in next week when I talk about something in history. Actually, a little bit. This will involve the Apollo program, actually. And part of the Apollo program that I have only ever seen one YouTube video on. And I've seen a lot of YouTube videos about this stuff. But in the meantime, though, I am just Astronaut, signing.